Then we have the variable attribute. The variable attribute is equal to the random variable in the current system. Actually, in the current system, the random variable is random variable attribute. That's why I just take the variable attribute. Because the variable is geometry. Actually, it's a non, right? So, and actually it's set to be variable if there are at least two different sub-attributes that can be defined on its name in an observation or experiment. That's easy. Yeah, now here, all the blue, namely in blue, are variable attributes, and the red ones are invariable attributes. But ID is not. So, in all the variable attributes, we have discretely variable attribute or discrete attribute, and the continuous variable attribute, because we have we often judge the object with their quality and the quantity, right? So we have the different two kinds of attribute. And here in this table, the name and the gender is, as well as the CHG is coronary heart disease, are discrete attribute, and the pink ones are continuous. Then population. The population is a set defined with all invariable and variable attributes. It includes all, everything, not just invariable attribute or variable attribute. It includes everything. And in the current system of the theory of probability, we have a specific term, population space. This is use the population to define a space. So the space is a general concept, but the population is a narrow concept in statistics. So here the space must have the all attributes of population. So the population is equal to population space. That's the same concept with same, because they have the same connotation. Scale. I introduced this concept into statistics to define scale space in order to replace the Cohen-Grove sample space. Cohen-Grove defined the scale space as a sample space. I think this is wrong. A scale is a measurement or judgment tool for observing the object, or a tool for statistical survey. For example, the statistical questionnaire is a scale space for the research project. It's complex, not just a single one. For example, to measure height or measure weight. In scale space for statistical survey include every scale. So it's a set of scales.
Li Gong, I think there's a question.
Yeah, can I get any question? You said that you disagreed with one aspect of scaling. I missed that. You said there was something about Kolmogorov scale. I think that's wrong.
Yeah.
What?
I don't agree with it.
You don't agree with it at all?
Yeah, I don't agree with him. He defined the scale space as a sample space. Actually, the sample space is a term. It's used as sample to image space, right?
Yeah.
The space is a general concept. The sample is a narrow concept in statistics. If we use the sample to define the space will have the same attribute with the sample. So actually it's the same concept. A sample is equal to the sample space.
Okay, and what is it that you disagree with?
I don't disagree with the sample space defined by column growth. So I adjusted the connotation of the sample space to scale space.
Oh, okay, so you're saying since they're handled in the same way.
I use a different term to replace the concept of the column growth.
Since the space isn't the same as the sample, you're giving them two different terms.
Yeah. I, in my opinion, a sample is equal to the sample space.
But it's
The
not
sample space is the sample itself. A sample space must be the sample itself.
Okay, so in the universe, there's a space.
Yeah.
Okay, and you're differentiating the sample that you take from the space out in the universe. Probably I'm holding you up, I shouldn't do this. Maybe I could ask you
We may discuss
I could ask you
after the presentation. Okay.
So your space is a specific space.
No. The space is the sample itself.
That's what I'm saying, in the sense that you're defining, say, in a universal location like here, you're saying that my space is your definition of space, that it's me, it's not in relation to the other independent players in this space. You're saying that him or me is a different object of that space.
We have the sample concept after this. The sample in statistics is not an individual. It's not equal to an individual. It is a sample. It's a set of n individuals, not just only one. An individual in a sample cannot be called a sample again. We need a rigorous conceptual system without any confusion or confliction.
But Li Gong, I don't understand what a space is.
Oh, the space is I think is a physical concept. Actually, we don't need space. This term we don't need, but in the current system we use this concept. So I would like to clarify the essence of the common growth sample space. What is the essence of the common growth sample space? I try to clarify it.
Well, you could just make it simple by saying a space is a set in which certain operators are defined. So addition may be defined, multiplication may be defined. That would be a common space.
Just because I introduced a scale, the concept scale into statistics as a professional term. So we'll have scale space. We can define. For example, this is a scale space for sampling. Here. For example, race. The scale space of the race is equal to y. And age is in this range, 35 to 140. We will find the the youngest is 38. So we can take smaller digit than this one. Each scale space marked in red for each attribute. This is the sample space of common growth defined. Yeah.
So you're saying that a scale space is to an attribute as
The scale
a
space
sample
I'm
space is to a
defined.
population.
the scale space I define is equal to the sample space defined by common graph.
This is just a terminology.
This terminology different. Actually, they are same. They are same.
Scale spaces you're using as a general term, and sample space is a specific term. Is that how?
Yeah, the sample space is equal to sample. It's the sample itself.
Right.
Yeah, that's why I define, because I don't agree with the common graph. It confused. It may cause confusion in some situations. Because the scale space is not equal to sample. The scale is not equal to sample. So we cannot use the sample to define the sample space like common graph did. Actually, the sample here, the sample here in the definition of common graph is equal to the scale, not to the sample itself. So we cannot use sample here to define the space.
It's a terminology.
It's terminology, but it's very important. It may cause some confusion, or we must adjust it. Random measurement or random distribution, these are mathematical concepts. Everything in statistics are random measurement. Nothing is certain. So after we have the measurement, we have the random distribution for every attribute. Then sample. A set of n of individuals in a statistical survey will constitute a sample. So an individual in a sample cannot be called a sample again. Otherwise, will cause confusion. I often heard someone told me, I have a sample. I don't know what exactly he said, or a set of the individuals, or an individual in a set. So I would like to create a new word, random individual, or randomly. This is in my system. This is a new word, randomly, means random individual. Everyone can understand. So a sample is a random set of n randomly. And this is the dialectic observation. This the definition in a dialectic logic. So a sample is equal to a set of n randomly. Is equal to a data set. It's a sample space. A sample is the sample space. A set of is equal to a set of random experienced facts in real and objective meanings to a subject or a statistician. This is a sample. It's not an individual in a sample. But it is not a set of purely abstract marks and numbers. Everything in a sample is not a purely abstract numbers. It has meaning. That's different from mathematics. So sample space. A sample space is a sample itself. This is because we use a sample to define a space concept. So the sample space must be equal to the sample because they have the same attributes. If A is equal to B, then A and B must have the same attributes. That's philosophical. Measurement space. A a measurement space comes from the current zero probability. Okay. As space is said to be measured, everything in it can be measured on a scale space, because we have introduced the scale space into the system. So a measurable space can be defined in this way. As a population is a measurable space, since all individuals in it should be measurable on the scale space defined before the research beginning. So measured space is because a sample is the measured space. Because the sample is the space.